Hi everyone. Our next unit of work is on Pythagoras' theorem and trigonometry. So Pythagoras is used for problems involving three sides of a right triangle where one is the unknown required. Pythagoras' theorem itself is for a right triangle, the sum of each shorter side squared is equal to the square of the longest side, which commonly we know as c squared equals a squared plus b squared, where c squared is the hypotenuse. And we've been doing this since year 7, so it should be pretty easy. Trigonometric ratios. Lots of people know this as SOHCAHTOA, or sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. So some things to note with this is we're dealing with a triangle ABC and we need a reference angle. The reference angle dictates which sides are the opposite, adjacent and hypotenuse. In this case, if that was the reference angle, that would be opposite, that would be hypotenuse, and the remaining side would be the adjacent side. The one next to the reference angle, that's not the hypotenuse. But if we chose this angle instead, as we did over here, this length would be the opposite side, this length would be the hypotenuse still, and this side now would become the adjacent side because it's next to the reference angle. And if we use our calculators, we can find sine theta, we can find the opposite side by multiplying the hypotenuse by sine theta. We can find the hypotenuse by dividing the opposite side by sine theta, and so on and so forth for each of the three different ratios. If we want to find an angle, take the inverse function, find the ratio, take the inverse function, gives us the angle. In all of these cases, make sure that we're in degrees mode on our calculator, which is important for now. To remember which go with which, SOHCAHTOA can help, but it is just a mnemonic. Sine is equal to opposite over hypotenuse, cosine is equal to adjacent divided by hypotenuse, tan is equal to opposite over adjacent. We do have some other formulas that we can remember. The area of a right triangle is half AB, where A and B are the sides adjacent to the right angle. We can also find the area of other triangles that aren't right by using half AB sine C. So we need to know that angle there. This side and this side would be A and B. And if we know that angle and the length of the two sides next to it, multiply them all together in the form half AB sine C, that will give us the area of this triangle. We can also use Heron's rule when we know all three sides. First find out S, which is just A, B, C added together divided by 2, and then substitute A, B, C and S into this equation, and it will also give you the area. If we have any triangle and we're given, we have an angle, a side, an angle, an opposite side, one of them is unknown, we can use the sine rule. If we're examining three sides and an angle, we can use the cosine rule. If we're looking at elevation in a diagram, it's from the ground up. If we're looking at depression, it's from a horizontal line down. And we have to be a little bit careful when we're dealing with accuracy, especially in trigonometry. Rounding creates errors, but similarly providing provision beyond that possible for measurement is similarly an error. So there's no point in having it to 6 decimal places if you can only measure to 2 decimal places, or if you've only been given information accurate to 2 decimal places. Precision of the final answer should be restricted to the precision of the initial quantities provided. It's not advised to round. It's advised to delay rounding until the last possible moment, and then provide precision to the right level of accuracy. And that wraps up our trigonometry review. Thank you.